It wasn't supposed to exist. A galaxy older than time itself, glowing in the darkness. When the James Webb Space Telescope saw it, the data looked wrong, almost impossible. But it wasn't an error. It was a revelation. Because this one image didn't just challenge our understanding of the universe, it shattered it. Everything we thought we knew about the first stars, the first galaxies, even the first seconds of time, might have to be rewritten. In the next few minutes you'll see what Webb has uncovered. Dark stars, powered by invisible matter, galaxies that formed too early to exist, and mysterious chemistry in the shadows of Saturn. The deeper Webb looks, the stranger the universe becomes. In July, Webb captured light from a galaxy so distant it existed only 290 million years after the Big Bang. A blink in cosmic time. Astronomers named it JWST 14-0. At first, it seemed ordinary, just another bright smudge from the ancient cosmos. But when scientists analyzed its light, they froze. The pattern of elements didn't fit anything known. No hydrogen fusion, no stellar fingerprints. Just helium lines, glowing strangely, steadily, as if powered by something else. Some theorists whispered the impossible, a dark star, not fueled by fusion, but by the annihilation of dark matter itself. Imagine a star whose heart is invisible, a furnace not of atoms, but of the universe's missing mass. Energy from colliding dark matter particles inflates it to colossal size, thousands of times wider than our sun, shining not from heat, but from the death of the unseen. If Webb truly caught a dark star, then for the first time in human history, we've witnessed dark matter doing something that glows. But what came next made even less sense. Webb kept looking deeper, and what it found shouldn't be there. Clusters of fully formed galaxies, massive and bright, existing when the universe was less than 400 million years old. Our models said galaxies needed 1 billion years to form, but Webb is showing them popping up almost instantly, filled with metals, dust, and complex chemistry that shouldn't exist yet. In one of them, Webb detected oxygen, a heavy element that only comes from multiple generations of stars exploding in supernovae. But how could there have been multiple generations when the universe was still an infant? Some astronomers began calling them impossible galaxies. Others called them ghosts of a faster universe. Either way, Webb's data was undeniable. The early universe wasn't slow, quiet, or simple. It was fast, bright, and full of violence. Stars were being born and dying in rapid succession, creating metals, dust, and even carbon-based molecules, the seeds of life, far sooner than anyone expected. And that raised a chilling question. If life's ingredients were already spreading this early, how many chances did the universe have before us? Then came another surprise. Galaxies that stopped forming stars almost as soon as they began. Astronomers nicknamed them Sleeping Beauty galaxies. They flared brightly in the first few 100 million years, then went dark, frozen in time. Why? Did something in the young universe shut them down? Or are we seeing the echoes of a cosmic event so violent it silenced entire galaxies at once? Webb's sensitivity has turned these faint ghosts into crystal-clear memories, windows into a time when creation and destruction were one and the same. But the strangeness wasn't confined to the early universe. It was creeping closer, into our own solar system. When Webb turned its golden mirrors towards Saturn, it saw something no one expected. Above the planet's north pole, right above the famous hexagonal storm, it detected dark, suspended beads floating in the atmosphere. They didn't match methane clouds. They didn't match water ice. They didn't match anything known. Infrared readings showed that these particles absorb heat differently than any molecule ever seen on Saturn. Could they be exotic hydrocarbon clusters, crystals of unknown composition, or something even stranger, a new kind of atmospheric chemistry? Scientists are baffled. The dark beads are still unexplained, and Webb continues to stare, frame by frame, as if the planet itself is hiding a secret. Billions of kilometers beyond Saturn, on a frozen dwarf planet named Make-Muck, Webb found something that shouldn't exist at all: heat. Its mid-infrared sensors detected an unusual glow, hinting at cryovolcanoes, ice volcanoes erupting nitrogen and methane into space. Makemake was supposed to be dead, a frozen relic drifting through darkness. Instead, it's active, alive, a world whispering that even the outermost corners of our solar system are far from silent. And it's not alone. Pluto, Haumea, Eris, these icy worlds may all be geologically awake. Webb is revealing a solar system still evolving, still reshaping itself, even after 4.5 billion years. But Webb's reach doesn't end with galaxies or planets. It's now peering into the dark nurseries of stars, dense molecular clouds where visible light can't escape. In these voids, Webb detected the faintest shimmer, hydrogen molecules vibrating, energized by cosmic rays. For the first time, scientists directly measured the invisible radiation that seeds the birth of new stars. These cosmic rays act like sparks, triggering collapse, heating dust, guiding chemistry. In a way, Webb is watching the birth of light itself. And if we can trace that process, we might finally understand how the first stars in history ignited and why the universe's rhythm still follows their pulse. Everywhere Webb looks, it finds contradiction. Dark matter that might glow, galaxies that age too fast, worlds that refuse to die. It's forcing scientists to rewrite everything, from the age of the first black holes to the structure of dark energy. Even the cosmic timeline, the sacred chart of creation, may be wrong. Maybe the universe didn't expand as smoothly as we thought. Maybe time itself stretched unevenly, causing pockets where galaxies grew in fast forward. Or maybe the laws of physics aren't universal after all. Webb isn't just showing us the universe's past, it's showing us ourselves. Because every atom in your body, every carbon, oxygen, and iron molecule, was once forged in one of these impossible galaxies. In the chaos of creation, stars lived fast, died violently, and scattered the ingredients for life across billions of light years. And now, 13 billion years later, the descendants of that cosmic fire are looking back. We built a telescope so powerful it could find our own beginning, and it's telling us that the story is stranger than we ever imagined. We began with a galaxy older than time. We end with a universe that refuses to make sense. A dark star burning without fusion. Galaxies born too soon. Worlds alive in the dark. Saturn whispering secrets through invisible storms. The James Webb Space Telescope hasn't just changed astronomy, it's changed what it means to know. Because the deeper we look into the cosmos, the deeper the cosmos looks back. And somewhere in that reflection, between the known and the impossible, we might finally see the truth. That the universe has only just begun to tell its story.